Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking in Geometry Part B. This is Lesson 13, and we're going to talk about chords, angles, and arcs. So let's just review some things that we need to know in order to be successful in this lesson. First of all, a chord is a segment within a circle that has endpoints on the circle. From Lesson 8, we learned that the measure of the central angle and its intercepted arc are equal. So we'll look at that in just a second. So here's a picture of that. So this this arc right here, CD, would have the same measure as this central angle right here. Remember, a central angle has its vertex at the center of the circle. And so here in this case, the measure of angle A would be the same as the measure of arc CD, and both of those would be 63 degrees. So those are things you've got to understand in order to be successful with some of these theorems that we're going to look at. So here are the first theorems that we're going to look at, Theorem 13.1 and its converse. So within a circle or any congruent circles, congruent central angles have congruent arcs. So here is a picture of this situation. So it says that congruent central angles. So in other words, if this angle is congruent to this angle, then these arcs have the same measure as well. They're congruent. So if angle DAC is congruent to angle BAE, then the arcs that they have in common, arc DC is congruent to arc BE. So real simple. Converse is the same thing, but it's backwards. So within a circle, congruent arcs have congruent central angles. So this is just saying this thing backwards. So if DC is congruent to BE, those two arcs are congruent, and those corresponding angles are also congruent. So quick example of this, here's our situation. If arc DC is 63 degrees, so right here, this arc is 63 degrees, then if DAC is congruent to BAE, what does EB equal? Well, EB is going to equal the same thing as this arc right here. It's going to be 63 degrees. And because of that, then those two angles are going to equal 63 degrees. All right, so let's take a look at the next theorem, Theorem 13.3 and its converse. So same deal here within a circle or congruent circles. Congruent central angles have congruent chords. So this is adding the chord to the central angle here. So here's a picture of this situation. So again, we talked about what a chord was, but here's an example of a chord. CD is a chord. It has endpoints on the circle. So make sure that you understand what a chord is. So if DAC, angle DAC right here, is congruent to BAE, then those chords that go through and have endpoints on that on those points on the angle are also congruent. So DC would be congruent to BE. So those chords are congruent. And then the converse is also true. So if we have congruent chords, then you also have the angles corresponding to them are also congruent. So if those chords are congruent, BE and DC, if those are congruent, then the angles that go with them are congruent. All right, so how are we going to apply that? So here's a situation. We've got this picture, and the only thing we're told right here is that BE is 15. So if DAC, if angle DAC right here, is congruent to BAE, then what do we know about DC? Well, that theorem just said that if the angles are congruent, and so are these chords that go through them. So those chords are congruent, so that chord would also be 15. So real simple there. All right, so here's the next theorem, Theorem 13.5. Within a circle or congruent circles, congruent chords have congruent arcs. So here is a picture of this. So here are the chords. We've got two chords. If these chords are congruent, then those arcs that have endpoints on the endpoints of that chord are also congruent. So if CD is congruent to BE, well, then arc CD is congruent to arc BE. So chords are congruent and the arcs are congruent. So the converse is also true within a circle. Congruent arcs have congruent chords. So this would be working backwards here. So if we know that these arcs are congruent, so if we mark these arcs as congruent, then the chords are also congruent. So here's a little more complicated example of this. So here's our situation. We want to find the value of x. So it looks like we have that these two arcs are marked congruent. So that means that these chords will also have to be congruent. So we just set up an equation. 12x minus 24 would equal 9x minus 15. We're going to solve for x. We're going to subtract 9x from each side, giving us 3x minus 24 equals negative 15. Solving for x, we're going to add 24 to each side, giving us 3x equals 9. And then finally, dividing by 3 gives us x equals 3. So real simple process here, just understanding how these arcs and angles relate to each other. So let's take a look at the next situation. 13,7 and its converse. So within a circle or congruent circle, chords equidistant from the center, or centers if you have two circles, are congruent. So here's what that looks like. So we've got two chords, and then we have these altitudes drawn from the center to those chords. If these two segments are congruent, then that makes these two chords congruent. And there's another theorem that goes with this one later on. So in other words, if BE, which is this segment from the center to the chord, is congruent to BF, then those two chords are congruent to each other. Converse is also true. If congruent chords are the same distance from the center, then those segments right here are also congruent. So if AD is congruent to CD, so this is backwards, then BE is congruent to BF. So we can do all sorts of little problems with that. Just understand, apply this theorem as you need to. So here's an example. So here's our situation. You see these two segments are congruent. Right here, BF and BE. So if we want to find the value of x, we're just going to set up an equation. 14x minus 26 equals 11x plus 10. Now solve for x. So we're going to subtract 11x from each side, giving us 3x minus 26 equals 10. Add 26 to each side, giving us 3x equals 36. And finally divide by 3. And so we know that x is 12. So just recognizing that since these two segments are congruent, and those chords that go with it are also congruent, helps you solve a problem. All right, theorem 13.9. In a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. So let's look at this situation. So here's a diameter, AB. Since AB is a diameter and it is perpendicular to this chord, then these two segments on either side of that diameter are also congruent. And that actually works if it's just a radius as well. If this is a radius and it's perpendicular to this chord, then these two are also going to be congruent. All right, so let's take a look. If AB is a diameter and AB is perpendicular to CD, then those segments will be congruent, and the arcs will also be congruent. So these arcs are also bisected. So here's an example of how we apply this. Looks a little complicated, but it's really not so bad. AB is a diameter, and CD equals 48. Well, we see that right here they're perpendicular. So that means that these two segments have to be congruent. And it looks like our job here is to find x. Well, we're going to have to apply, first of all, the rule saying that these two are congruent. Since the whole segment's 48, and that means that CE right here would have to be half of 48, which is 24. And so now we got a segment right here that's 24. We got a segment here that's x, and a segment here that's x plus 18. It is a right triangle. So guess what? We're going to apply the Pythagorean theorem. So applying the Pythagorean theorem, a squared plus b squared, remember b squared is CE, which is 24, equals c squared, x plus 18. So a squared plus b squared equals c squared. And so there is our Pythagorean theorem. Simplifying it, 24 squared is 576. X plus 18, we have to use FOIL or multiplying binomials to do this. You learned about this in Algebra 1, probably even in pre-algebra. And so if you work that out, you get x squared plus 36x plus 324. We've got x squared on each side, so those are going to cancel each other out by subtraction. And then I'm going to subtract 324 from each side, giving us 252 equals 36x. One-step equation now, divide by 36, x is going to equal 7. So if x is 7, you could also be asked, what's this segment? Well, 7 plus 18 would be 25. So I hope this helps you with some of these arcs, angles, and chords. If you struggle with this content as you're working out your assignment, please let me know in a teacher message. Make an appointment for a help session.